Okay, so welcome to the second lecture. As usual, we will do two breaks like what we did last week. Each one break at each hour, so that we can just take a break, have some tea, coffee, and just rest a while before we continue. I hope everyone's okay with that. For the two short breaks. All right, I guess so. Silence means consent. All right, so today we are talking about time value of money. Perhaps it might be the most critical topic because after this lecture, subsequent lectures will require your knowledge on time value of money in order to answer the questions or proceed. So there are two parts to the lecture. So today we'll cover part A, part A, and then there's actually a pre-recorded lecture that is already uploaded on the tutorial site, and you will see that as lesson 2B. So how I structured this lecture is that lecture 2A, which is what we are doing now, it covers all the concepts, all right? And we'll go through some problems as well. But lecture 2B goes through entirely problems. So questions relating to this topic. And if you compare with other lecture or other tutorial classes, they actually combine both of it, but I feel that there's not enough time to cover the concepts well. So that's why I split all the questions or most of the questions in a pre-recorded lecture. And so it is mandatory to look through, especially before you prepare or before you start doing your TMA. All right, so there are two parts. So one, you have to watch on your own, part 2B, and 2A is this live lecture. And I'll encourage, as usual, if you have any questions, especially for this kind of calculations, how to use the Excel formula, etc., feel free to just unmute yourself or even just type in the group chat if you like. And the main objective is to answer your questions in the live lecture. All right, we're good. Okay. All right, so time value of money, let me just move on to this, basically is grounded on the concept of simple interest versus compound interest, right? So simple interest is basically just interest on the main principal, right? So you only gain interest on your principal, right? But compound interest, I believe this is probably more of like primary school kind of concept, is that you have interest on the interest amount. So the most basic example I like to highlight here is that suppose you have $100 in the bank, right? And then the thing is, how much will you have after 2 years if the banks will pay you 10%? So a simple interest is you just take, $100 times 10% times 2, right? And this is the amount of interest you get in 2 years. And then you just plus back the principal, and this is what you get. Now, compound interest, we know that we need to get the interest on the interest. And therefore, we have this thing where we need to square it, right? So we have 100 plus 1 plus 10% squared. And you notice that, of course, a compound interest, you'll get slightly more interest amount. Right? So these are just a very basic concept. So in finance, we never ever use simple interest. All right. So it's always compound interest. And so this is the basic of what is a compound interest. And so in this example, we have this $10 deposit for 5% for 200 years. Right. So how much will the investment worth today? Because this $10 was deposited 200 years ago. So we can just use the compound interest formula, or just now what we did, which is 1 plus 5%, right? To the power of 200, because we have 200 years. And so this is the value of these $10 today. Of course, if we calculate the simple interest, this is we just take 200 times the 5%, or actually that's $10 times the 5%, multiply by 200 years, and basically you only get $100. So what is this showing is that, compounding kind of add a lot of, I guess, interest to your amount, right? Because the difference is so much. So this explains kind of like, the power of compounding, whereas your number of years increase, it becomes almost exponential. The amount that you get at the end is exponential. A small side note is like, so it encourages you to actually save early, right? Make some small savings, and so that your amount can grow as the number of years increase. Right. As usual, if you have any questions, feel free to type in the group chat. So that's just for compound and simple interest. But we'll first want to tackle about this idea of number of compounding periods. So this is very important. What's the number of compounding periods here? Okay. So in most cases, when we think about compounding, we always think about annual compounding, meaning what? Every year we only compound once, right? In this sense, we have, remember, 2 years. We do it for 2 years at 10%. So we just do this once and for 2 years here. All right. So this is an annual compounding, which is kind of, what we have seen so far, right? But let's say if we have semi-annual compounding, what must we do? First, the very important step is your interest rate, all right? You need, because it's semi-annual, you need to divide it by 2, because it's semi-annual. But at the same time, your number of periods of compounding, right? Because now, remember, so you have 2 years, if it's semi-annual, means what? You are compounding, each year you must compound twice. So the total number of compounding periods becomes 4. So there are 2 things that you need to do. First, you divide the rates, then you multiply the number of periods, because the number of periods increase. All right, so let's look at monthly compounding. So monthly compounding, again, is the same. Now we need to divide the rate. This rate, okay, so this rate, 10% interest, right, is always assumed, if in the question, is always assumed to be in a year. So in this case, what it means is that, if it's every month, you know that 1 year has 12 months. So you need to divide the rate by 12. But then the number of periods, now you need to take 12 times 2, because every month you're doing it. So it's 24. Total of 24. So this part, I guess, might be very intuitive, like, oh yeah, you should multiply the rate, multiply the period by the number of compounding per year, and then divide the rate by the number of periods per year, right? Like semi-annual divide by 2, monthly divide by 12, and then the number of periods you times 2 and times 12. So I guess these are quite intuitive, but I want to highlight to you that usually in questions, maybe when you look at some past year papers or even your TMA, this component here usually becomes forgotten. It's like you can't, of course, there's so many things in the question, right? So you missed it out. So I want to highlight that always remind yourself the first thing to do is to see, okay, in terms of compounding, whether is it annual, is it semi-annual, or is it monthly? And make sure you do the division of the rates here. So make sure you do the division of rates and the number of periods. So always remind yourself. So this is the first thing that you should take note of. All right. I will not go through this continuous because you will not be using it. But daily is the same, so you divide by 360. We have okay. So that's the example. But the next thing we like to talk about is this idea of annual percentage rate, or we call it nominal rate, versus this other thing called periodic rate. So what is nominal rate? Okay, so the terminology is quite important because we'll use this idea of nominal rate, or APR, in subsequent lecture as well. So we need to understand what it means. So the nominal rate basically is the annual rate that's quoted by law. And nominal is basically what is being stated. Like if you have I don't know, a bond, right? So a bond will tell you what is the remember last lecture we talked about sorry, not last lecture. We haven't talked about it, but okay, we not talk about bond, but let's just think about nominal rate as being the rate that is being quoted by law is an annual rate. All right. Later we'll talk about bond. And so the thing is, for the nominal rate, if you divide it by the number of periods, it gives you the periodic rate. And this formula is not something that's been like just thought out. If you just flip back to the last slide, you notice that this, for example, you do semi-annual, this 10% here is basically a nominal rate. And this is the number of periods that we divided. So 10 divided by 2 becomes the, so 10% divided by 2 becomes the periodic rate, which is the formula that's given here. All right, periodic rate. So this is the definition of periodic rate. Basically, we take the nominal divided by the number of periods. All right. There is an example here that we can see. So let's say if we have a APR or nominal rate, and if it's the monthly rate is 0.5%, the question is, what is the APR nominal rate? So basically the monthly rate, this is your periodic rate. And we take, since it's a monthly rate, we multiply by 12, it will give you the nominal rate. So nominal rate is 6%. Now, I want to highlight that this monthly rate means that it is a rate based on monthly compounding. So remember when we talked initially about the various annual, semi-annual, and monthly, you must consider what is the compounding before you can calculate the nominal rate. Okay, so if you don't understand that, no worries, we have a question just below here. But before we go there, we have this another question on semi-annual. So let's say the semi-annual rate is 0.5%. What is the nominal? So nominal is always on annual, right? So we just multiply by 2. Now, this question here says, so what is the monthly rate if, so you're looking for monthly rate, if the APR or nominal is 12% with monthly compounding. So you notice, first of all, is that both are monthly. So we are looking for monthly rate, and this 12% is based on monthly compounding. And this means that, okay, we can calculate the monthly rate basically is the periodic rate, right? So we just take 12 divided by 12, right? Because, the nominal is based on annual. So we just divide by 12, we get 1%. All right. But the question says, can you divide the above nominal or APR by 2 to get the semi-annual? So this is where the earlier question come in. The answer is actually no, because let's say, because this APR of 12% is based on monthly compounding. So let's say you want to find the semi-annual rate. We cannot do it. We can't get, because this is semi-annual, right? But this is based on monthly compounding. So no, we cannot do it because the APR is based on, because you need the APR that is based on semi-annual compounding in order to find the period rate for semi-annual. So this is a important concept. Everyone get that? Do you need me to explain again? So the answer is no, you cannot divide 12% divide by 2. So you cannot do 12% divide by 2 to get the semi-annual. Equals to semi-annual. So it's not equal. You cannot do that because your 12% is based on monthly compounding. Unless you have unless the question say, oh, your 12% is based on with semi-annual compounding, then you can take 12% divide by 2 to find your period rate. That one's okay. All right. So just now we talk about APR, we talk about APR or nominal to find the period rate. Now, in all questions, whatever rate they quote you is the nominal rate. All right. Now, the thing is sometimes the periods that you have, one can be, let's say, semi-annual compounding and one can be annual compounding. So the question is which, let's say, if you have an investment, right? One is giving you annual compounding, one is giving semi-annual. So the question is which one is better? And to answer that question, we have to use this effective annual rate. Okay. So effective annual rate, basically, we are converting the rates given based on the various compounding. Can you see here? So the nominal divided by M. So M is the number of compounding periods. So we are converting this rate based on, let's say, M number of compounding periods into a rate as if it's only compounded once a year. So it's as if it is compounded once a year. All right. So that we can do comparison. That's the main thing for effective annual rate. So this example here, we have a semi-annual compounding. The nominal given at 10% and 1 year. So what is the effective annual rate? We basically take the nominal, which is 10% divided by 2 because it's semi-annual, right? So we take 10% divided by 2, and because it's semi-annual, M is 2, all right? And so we can get the effective annual rate here. So this is using the formula. Because we can use Excel even for your final exam, we need not do this. We can use Excel to calculate for you. So this is an example here. We have a 5%, a 5.25% saving account, which is compounded daily. And we have a 5.30%, which is compounded semi-annually. All right. So these two are what rates? Anyone know? So these two are considered what rates? Are they considered period rates? Are they considered nominal rates? And give it a try. You can just type in the group chat. Are these period rates? Nominal rates? That's good. Yeah. Thanks. Yeah. So that's right. So these are nominal rates, right? So these are not period rates. So what we do is, so how do you get period rate? Let me just recap the formula. So if you get a period rate, it's 5.25 divided by 365. So this is a period rate. So if you want to calculate the effective rate, very simple. We just use this formula called EFFECT. We plug in the nominal rate given and the number of compounding periods. So if you have the Excel view, give it a try, see whether you have any issues. And so, yeah, you can get your effective rates here. So it's pretty easy with Excel to do this kind of comparison, right? Okay, so those are about rates. There's this rule here about rates is that if you want the number of years to double the investment will be given by the rate required for the invested sum to double in a certain year is given by this idea of a rule of 72. So for example, the number of years to let's say in this example, you have 12% kind of let's say savings account, right? And you want to double this amount of money. So how do we do it? We take 72 divided by the rate of 12%, give you 6 years. So 6 years is the number of years required to double your money. Now, another example, it could be what if you want to double money in 5 years, what is the rate required? So we just take 72 divided by 5, and this is the 14.5% is the rate required in your savings account to double your money in 5 years. I want to highlight to you that in this rule of 72, this is basically an approximation. So I repeat again, it's approximation. So whenever you look at questions, read the questions carefully, right? So if they say, let's say, calculate the rate required, let's say calculate the rate required, to double the amount of money. So if they say calculate, you cannot use the rule of 72, right? Rule of 72 is an approximation. If they say approximate, then you can use the rule of 72. So please be careful when you look at questions. Of course, if they say calculate and then you use the rule of 72, I guess you will still get some partial marks, but then you will not get the full marks, right? So be very cautious. The rule of 72 is just an approximation. Okay, so we are going to move on to now the idea of the time value of money component. So this now is more of like the background of like rates and all, right? So the idea of future value is, it might be a bit intuitive, like it's easy to understand. So the idea of future value comes about in a sense that, oh, let's say you have $100, right? And you want to put it in a saving account for 3 years, and the saving account is giving you 4% interest. So what is your final value? So yeah, you can use future value. So what your final value is basically your future value. So what is the value in the future? All right, so this is the example here. 4%, remember we only can use compound interest, we cannot use simple interest. So if you use only compound interest, after the 3 years, this is the amount we get. And we kind of already saw this kind of formula, right? Remember in the first few slides when we talk about compound interest, yeah, basically this is a compound interest formula. So the future value is basically what's your present value, which is $100 times 1 plus the rate was 4%, right? And we are doing this for 3 years. So doing this will give you the future value immediately. Okay, so before we move on, I'd like to highlight the, as usual, the intuition behind why do we even care about time value of money, right? Like why does it even matter in the first place? So if anyone asks you like why do you even study time value of money, the answer to it is that money that now is worth more than money later. All right. I repeat again. So money now is worth more than money later. And the reasoning behind is that because we need to consider the idea of almost like an opportunity cost. All right. So what does this mean? If you are given the money now, right? Let's say I give you $10 now. You can actually invest these $10 to do something, right? I don't know what you want to do. Maybe you want to put in a saving account, maybe you want to buy stocks, etc. But you can do it. You can use the $10 now to do something with the money, to grow your money. As compared to money which is given to you later, let's say in 1 year's time, you might not be able to do that, right? You must wait 1 year later, then you can take the money to invest it. So because of that, time kind of affect the value of your money. And in this example, like even the future value, we can see that if we have a $100 now, it can be worth 112 in 3 years. So this is the idea of time value of money. So the intuition behind it is that money at different points of time is worth different amount of money or different value, right? And because of that, there is an important concept that I want to highlight to you here. All right, let's say I have this timeline here, 0, 1, 2, 3, 4. If I have $100 here, is this $100 still worth $100, let's say at 4 years? Like I shift it to 4 years. Anyone want to give a try? Is this $100 still worth the same amount of money? If let's say I shift this $100 to 4 years, or at the 4th year. Okay, so maybe I'm not too sure, but the short answer is no, right? So like I repeat. Yeah, okay. So yes, you have to account for change in economy, but more importantly, you have to account for what you can do with the money, like in terms of investment, right? And therefore, For example, this $100 can be invested in savings account, right? The risk-free savings account, and therefore generate some money for you. So the again, the intuition behind it, if you forget everything, this lecture, of course you shouldn't, but if you do, the intuition or the bird's eye view concept is that money at different point of time is worth different value. So to be a bit of a broken record, I'm going to repeat this again. So if I have $100, $100. So I have $100 at year one, $100 at year two, $100 at year three. So which $100 worth more? Anyone can figure out which $100 worth more to you? Yeah. Oh, thanks. Precisely. Yeah. So $100 in year one worth the most money because of the idea of time. All right. So this is a very basic concept, but why is it important is that you should not treat $100 year one, year two, year three as the same. So if you add, let's say $100 plus $100, so let's say I ask you what's the total value of your this so-called this thing here, it should not be equals to 300 because there's idea of time that comes to play, right? You need to do some calculations, which we'll look at later. So it's not equals to 300. That's the important concept. So at the end of the day, after this course, if as a finance or taking a bit of a finance module, you should not say that this 300 in year one, year two, year three equals to 300. No, it's not equals to 300. All right. Okay, so we carry on with future value. So we have this Manhattan Island, which was worth $24 only in 1626. So we are asked to calculate the future value of this $24 if it was invested for 393 years. And in this sense, these 393 years, we are assuming, of course, annual compounding. So if the question did not say it's always annual compounding, at a rate of 10% per year. Okay, that's good. They actually say 10% per. No, they actually didn't tell you what's the compounding period, but it's annual. So what we can do is we just take 24 plus 1 plus 10% to the power of 393. All right. So let me see. Maybe at this point in time, I just want to quickly show you how you do in Excel. Let me just share my screen on Excel. So if you can try to follow me on Excel to do this. So I'm just going to repeat this question, but this time on Excel. So I'm going to use my FV formula. So if you have Excel open, feel free to follow me. So FV is the same thing as future value. So basically, we don't really need to know this formula. You can just use Excel to do it, right? So what is the rate again? Let me see. The rate was 10%, right? 0.1. The number of periods, so MPR is the number of periods, right? So MPR is number of periods. We say it's 393. Okay, so payment, we have not learned this, but let's just put as 0 first. There is nothing there. The present value, we know that the present value was 24, right? Because it was purchased at $24. Type, we can always put at 0. We'll talk about it in a bit, but we'll put at 0 at the moment. And this is what you should have gotten, right? Which is the answer 4.4 times 10 to the power of 17. All right, everyone could get that. Okay, so I believe everyone should be good. All right. So now, let's talk about a bit on the timing of cash flow. We have covered a little about it, but let's think about this cash flow. So when we do timeline, something to take note of is that we always start from year zero. Okay, so year zero, year one, year two, year three. That's how we do a timeline. All right. And there's this convention which is very important. And how I like to think about it. So I always think about it this way: is money going out or is money going into your pocket? Okay, I repeat again: is money going in or is money going out of your pocket? So if money is going out of your pocket, it will be a negative, right? So it's a cash outflow. So always take the perspective of your pocket. So if money is going into your pocket, it will be a positive. And this is important because in your Excel, where you put in the values, you need to put the negative or positive. If not, you'll get the wrong answers. All right. So I repeat again: if money is going to, always take the perspective of your own pocket. If money is going into your pocket, it is a positive. If money is going out of your pocket, it is a negative. Okay, we'll have a few questions and we'll look at it. How to do it. Of course, there are 4 ways. At the end of the day, we'll focus only on Excel. Feel free to use the financial calculator, but we'll not be teaching it in the module. But if you have any questions, I'm happy to answer them as well, because I've used the financial calculator previously. Right. So we have already went through how we input the FV formula in Excel. All right. I will not go through the financial table because you'll never ever use this since you have Excel now. All right. So everyone's okay with future value? Is everyone good with that? All right. Okay, very good. Then we'll move on to present value. Okay, so future value is a bit easy to understand, right? What's the future value? What's present value? So present value, right? It's almost like this. You have 0 year, 1, 2, 3, let's say 4. Let's say I give you $100 in the 4th year. All right, and of course, this is positive, means money is going in your pocket in the 4th year, right? So what is the actual present value? What's the value now? What's the value now? What's the value now? Question mark, right? So how do you calculate a value now? Basically, it's the present value. What's the value now? And how we do present value, basically, it is, if you notice, if you do you remember your I don't know, secondary school mathematics? Remember your X-Men kind of method? I don't know where a teacher taught you this X-Men. So basically, it's just a formulation of your FE, right? So your future value equals to present times this whole chunk here, right? And basically now present value, you just put the FV divided by the rate here, right? So if you do remember, yeah, your cross your X, where you can actually get your future value. So if the rate is positive, all right, if the rate is positive, your present value will always be less than future value, right? Why? If you are getting, remember the broad intuition about time value of money. If you're getting money at the 4th year, it means that it's worth less, right? Than if you get money, you get $100 now, right? So the intuition is that, oh yeah, of course, if your rate is positive, your present value will always be smaller than the future value. Right? So let's say we have $103 here, right? So we have 103, which will be to be received next year. And the question is, how much is this 103 worth today? So in a simple sense, we can just take the 103 divided by 1 plus 3%, and this is 1 year, right? You get $100. But don't worry, we do not actually need to remember this formula. There's I think 2 or 3 formulas that we need to remember, and I'll highlight to you. But present value we can use Excel to do present value as well. And in the next question, I'll show you how to do it. But let's read the question. Suppose you bought a new computer for 3,000. All right, the payment is due in 2 years, and you can earn 8% of your money, right? How much money should you set aside today in order to make the payment due in 2 years? All right. So in 2 years, this $3,000 should we put it as a negative or positive value? Anyone give it a try? In 2 years' time, because this payment is only due in 2 years. Should you put it as a positive or negative? Negative. Very good. Yeah, because money is going out of your pocket, right? You're going to pay in 2 years. All right. So you know what? I'm just going to jump back to the Excel. So you'll see me jumping here and there for the first few examples so that we can understand more on how we do it. Okay. So we are going to use our PV formula now. So PV. All right. So as usual, if you have Excel, follow me how to do it. So rate. So what's the rate? 8%, right? 0.08. So remember in Excel, the rate, you have to put it in the decimal, not 8%. You put it as a decimal. Number of periods, we have 2, right? Because this is based on annual compounding. So it's just 2. Payment, let's just put as 0 first. We'll talk about it later. FV. So FV, remember just now I posted a question, whether it's negative or positive. So now you need to put negative. Negative 3,000. We know you pay negative in 2 years' time. Height, let's put as 0. And this is the answer that we should get. So this is the amount of money that we kind of need to have now, right? We need to have this amount of money so that we can pay the 3,000 outflow in 2 years. Okay, so this is the amount you get. Now we have one more question here. So suppose you want to borrow 200K pesos for 1 year. So we have 200K pesos for 1 year. Interest rate is 12%. And you and lenders agree that the interest on this loan will be this amount of money. Okay, so it's just 12% times the amount you borrow. So the lender deducts this interest amount from the loan upfront and just give you this amount. Now, before doing any calculation, do you think there's something wrong here? And if you think so, what is actually wrong? Before doing any calculation to verify. Anyone can give it, I don't know, just some suggestion. Is it wrong or is it actually correct? You can just do that. You just deduct the interest, right? You just deduct straight away. So it's easier. Then you don't have to pay the interest like later in the years. You just deduct straight away. You just get lesser amount of money in the loan. Anyone like give it a try? Is this wrong? Why is it wrong? Or is it correct? Should you do this like that? Okay, yeah. So I think at least you got it there. Yeah, very close. Yeah, you are kind of right. You managed to understand the idea of like the time difference. All right, very good. Yeah, I think I see some answers. Yeah, the amount you get less after each payment. Yes, yeah. If it's amortizing kind of loan. So the interest is different every year, yeah, because you're thinking about amortizing, right? Amortizing meaning that the loan amount decreases, so interest change. So yeah, all of you are correct. So yes, it's wrong. Okay. if we think about it as a time value of money question, concept, is that, yeah, your interest, if you pay now, is worth more than the interest you pay later. And of course, if it's an amortizing loan, amortizing meaning that the principal keep on decreasing, then yeah, your interest amount should kind of decrease as well, right? So yeah, all of you are correct. But let's verify this answer. So let's just use the idea of time value of money, right? I'll just jump back to the Excel. So can follow me on this. Now, my purpose of this question right now is I want to calculate, is the rate of this loan actually 12%? So they say it's 12%, right? But is it actually 12%? So I'm going to use this rate function. So if you can follow me, just use rate function, all right? Now, we have the number of periods which we know is 1 year. So this is not too contentious. Payment, let's go at 0 first because there are no payments. All right. Now the question is PV. What is the amount that we should put? And is it a positive or negative? Anyone like give it a try? Is it a positive or negative? Positive. Okay, you're right. But what's the amount that we should put here? No. Okay. So yeah. Okay. Yeah. Okay. Right. So 176000 is the right answer. So you should put 176. Give me a moment. 176. 1, 2, 3. Why? How do you get 176000? We need to remove away the interest, right? Because the question say that this bank, I guess, will take away your interest immediately, right? So it's 176000. And it's a positive, right? Because money is going in your pocket, right? The bank is going to give you this money. Now, FV, what is the amount and should it be negative or positive? All right, we have some answer negative, that's right. But what's the amount that we should put here? It will be the full loan amount, right? Yeah, that's right. We are getting there. Very good. Very good. So yeah, it will be a full loan amount that we have to pay back the bank, right? And why is it negative? Because the money is going out of your pocket now. We're going to pay back, right? So very good. Type, let's just put at 0 again. And we should get 14% here, or 13.6%, right? So now, if we compare 13.6% with what was stated in the question, they say the interest on this loan is 12%. Can you immediately see that, hey, you know what? The bank is actually charging you more than 12% by simply taking away the interest at the start. And the reason behind, again, goes back to the idea of time value of money, right? Because you're paying the interest immediately, you're actually paying more compared to paying later, right? If you pay later, it's worth less. You pay now, it's worth a lot more. So this is the idea of again, time value of money coming into play. Is it the effective? Yeah, okay, so that's a good question. So 13.6 is the nominal rate, but the nominal rate is exactly the same as effective rate. Why? Because this is a 1 year and it's annual compounding. So actually it's exactly the same. But what you actually calculated is always the nominal. If you need to convert it effective, you need to remember use the Excel effective formula, right? But in this case, because it's 1 year, and the annual compounding period is also 1 year, so it's exactly the same as effective. Okay, sure. So why is it negative? So remember, you are borrowing money. So you are getting, first of all, when you borrow money, you get the money now, right? So what you're getting now, the present value is 176,000, right? We talk about it because we take this minus this. So the present value is positive to you. You're getting the money. You're getting money in. But at the end of the day, the future value is negative 200K. Why? Because at the end of the loan, you have to pay back the bank, right? Because you're borrowing money. So initially the bank gives you the money, and at the end of the day, you need to pay money. When you pay back the money, because money is going out of your pocket, it becomes a negative here. So always remember, based on your position, is money going in of your pocket, into your pocket, or out of your pocket? So at the start, it's going in, so it's positive. At the end, you need to pay back the bank, so it's negative. The money is going out of your pocket. So in this case, if you have flipped the sign or you mess up the sign, your answers will be wrong. So it's important that you need to know whether money is going in your pocket, which is positive in this case, into your pocket. And at the end of 1 year, you need to pay back the bank. So money is going out of your pocket, and therefore it's a negative here. All right, that's clear. Okay, so some terminologies. Basically, when we see the idea of I or interest, there are various terms, and it can be said to be like a discount rate, cost of capital, opportunity, cost of capital, required return. So there are various terminologies. You will see the questions having this kind of terminologies, and so you just need to take note of them. They actually just refers to I or interest. And we'll actually go into detail what is cost of capital in the next lecture. Okay, so this is just a repeated slide. It's kind of summarizing the idea of time value of money again for you, that money that you have now is worth more than the money that you have later. Right? So this basically just try to summarize again why time value of money is an important concept. Okay, so the question here I'd like to pose, and I hope all of you can get the answer right, is which one will you prefer? Receiving $1,000 today or receiving $1,000 1 year from today? Which one is better? Which one will you prefer today? Very good. Okay, so yeah, very good. So today, you want today, right? Because of time value of money, right? So after today's lecture, if you talk to whoever, maybe non-finance or non-management people, your other friends from life science and all, you can tell them that if they owe you money, right? For example, if you go out for a meal, they owe you money. If you are very calculative, and you have gone through this lecture, of course, you will say, oh, you want them to pay you immediately, right? You don't want them to owe you for like 3 years, or not 3 years, maybe like 3 months, and then pay you after 3 months, right? So you want the money today. So yes, you'll prefer money today. All right. So the implications is that the same amount of cash flow or money is worth different at different points of time, right? So we have talked about this. And the reason why is because we can invest this money if we receive it now for something, and therefore it grows the money, or it makes the money more. So there are various implications. We will cover this in the next few lecture. We'll talk about this today, and we'll unfortunately not talk about this module here. All right. So let's just give this example a try on Excel. If you can do it on Excel, that'd be good as well. So suppose you have a 1-year-old son, you want to provide 75,000 in 17 years. All right. So you currently have 5,000 saved what interest rate must you earn to have 75,000 for your son in 17 years? All right. So first question, you currently have 5,000. So we know, okay, first of all, we know that we are going to calculate interest rate. We need to use the rate formula here. All right. Let me just go to Excel so we can just work this together. That will be easier. Okay, so I'm going to use the rate formula again. Number of periods. Anyone can say how many number of periods it is? It is 17 years, right? So 17. Payment, let's go at 0 again. Okay, present value. Now, is this a positive amount or negative amount? And what is the amount? Okay, I see there are some mixed answers already. So the correct one is yes, negative 5,000. Okay, let me just write here negative 5,000. Okay, why? Why is it negative? Because you want to invest this money for your college, for your son's college, right? So you're actually taking money out of your pocket. This 5,000. Yes, that's right. Money is going out of your pocket to grow it for your son's college fund. So yes, it's negative. Okay. Okay. If you cannot get why it's negative, think about it. You want to get 75K at the end of 17 years. So 75K is almost, I'm going to write here now, 75K is a positive amount, right? Because you want 75K into your pocket after 17 years. 17 years, right? That's right. So it means what? You are actually putting 5K out now. So it's negative. That's right. So money is going out of your pocket. After 17 years, you will receive 75K into your pocket. So now it is a positive. Okay. And 0. So anyone has issues with this idea of negative and positive, whether it's in and out of your pocket. So, or everyone is good with this concept. Why is negative 5,000 and why is it positive 75,000? Okay, good. So we should get 17%. Yeah. Okay. Oh, there's actually a typo here. It's not 5 years. It's 17 years. There's this small little part about guessing, but it's not important, is that we usually get this idea of guess. You don't really care about it, and we don't even consider it. Basically, it is about Excel will do various iterations in order to converge to a certain value, but when the convergence of the value is kind of easy, basically you don't need to do any guesswork, right? This is not very important, but just an FYI. We'll not go through based on the table because it will never be used. All right, so far everyone is comfortable with this idea of present value and future value, right? Because the next part, what we're going to do is we're going to talk about cash flows or cash coming in at various periods of time. So remember, previously we have only talked about present value and future value, right? So one like lump sum of money now and receiving a lump sum of money at the end. But usually that's not the case, right? Because sometimes we have things that come in between. So let's say we have, year 1. So previously we have always talked about 1, 2, 3, and 4, and 5. Let's say at 5 years. Present value is here, future value is here, right? We have always talked about, okay, what's the present value, what's the future value? The value at year 1, and actually no, we know what present value is supposed to be year 0. It's wrong. So present value is year 0, and then year 5, future value. Now, this is usually not the case because we have sometimes various C, which is cash flows. Cash flows happening in between, like intermittently, right here, like in year 2, year 3, year 4. And so how do we do about it? How do we handle this? So we handle it using this idea of multiple cash flows. All right. And we can see this as, so we are calculating the future present value of the multiple cash flows. So we basically, for every single cash flow, all right, I'm just going to write this here. I'm going to put C as cash flows. So for every single cash flows, we have to, if we are calculating the present value, we have to present value it. So bring it back to year 0. So we need to do it like this. For every year, we bring it back to year 0. But the number of times that we are discounting meaning we are bringing back, would be more and more. Okay, what does this mean? Can you see that if the cash flow happens in year 1, you basically need to discount it by 1 year, right? 1 year. But if the cash flow happens in year 2, we need to discount it by 2 years, right? And then cash flow happens in year 3, we need to discount it by 3 years. So basically, we're discounting more and more. That's how we can think about it. What I usually like to, how I do it, how I don't make mistake in the number of years I discount, I usually like to think of this idea of like a bunny hop. Just for fun, bunny hop. So how this bunny hop works? So if you are year 1, you have a cash flow in year 1, your bunny will hop. Bunny meaning like a rabbit, will hop 1 time, right? 1. So this is, you need discount by 1 year. If you have cash flow in year 2, your bunny will hop 1, 2. So you need to discount it by 2 years. And in year 3, the bunny will hop back how many years? 1, 2, 3. So for this one, you need to discount it by 3 years. So that's how I remember it. Just, kind of like sometimes you want to entertain yourself and for you to be easy to remember, right? So you think of it as like a bunny hopping back. So that's what I like for the fun of it. All right. Okay. So before we move on to this question, let's take a quick, let's say 6 to 7 minutes break. We'll come back at, let's say 8:08. So take a quick, go to the toilet, have some coffee or tea, and we'll continue. Right. And of course, if you have any questions, feel free to just type in the group chat during the break. All right, welcome back. Okay, yeah, we have a question on the pre-recorded lecture. Okay, so the pre-recorded lecture is in our tutorial group under the tech modules. So that's where you'll find all your basically all your lecture recordings as well. So it's under the tutorial group under modules. And then you'll see the various lectures. So last week's lecture was also posted there. Right? Okay, so let's look at this question. So now remember we are dealing with multiple cash flows now, meaning that cash flows happening in various years. So let's see this question. So an auto dealer gives you a choice to either pay 15,500 now, or make 3 payments, right? 8,000 now, 4,000 at the end of the following 2 years. All right, the cost of money. So you see there are various terms that are used. So in this sense, cost of money. So cost of money is 8%. Which one would you prefer? Okay, so you know option 1 is you're just going to pay 15,500 now, which is here. And option 2, we are going to have various things, right? I'm going to go over to Excel to show you how to do it, even though the answer is actually below here. But if you can, try to follow me on Excel so you can see how do you just type in the formulas. Okay, so I have my Excel open. I have just done this table here. So we are doing option 2 now. So for option 2, we know that we are getting 8,000, or we have to pay 8,000 in year 0, which is now. And 4,000 in year 1 and year 2, which is given here. Okay, so if we want to do the PV method, let's do the PV method, which is what we have learned so far. All right, so let's do PV. So PV. Okay, so first of all, we don't need to do PV for year 0, right? Everyone can get that because year 0, there is no PV, it's already year 0. So there's nothing to do for year 0. Now, for year 1, let's do PV. So you can follow me. And then we have to put in the, let's see, the rate. So rate is given at 8%, 0.08. Number of periods. Okay, so number of periods, we know we need to discount it by 1 period, right? 1 bunny hop, right? So I can just put it as a reference cell. I'm just going to put as year, tag to year 0 here. And the payment, let's put as 0 for the time being. Future value is 0 as well, because at the end of the day, you have to pay off, right? There's no future value that we will consider. Let's go at 0 as well. Right. Oh, sorry. The present value, I think I missed out. Oh, sorry. Future value is not 0. Future value is 4,000 here. All right. So this should give you an answer. Now, can anyone see, was there a mistake that I've done in this here? Has there been a mistake? Yeah, that's right. Very good. So, because you're paying money, right? So it's supposed to be negative. All this must be negative because you're paying money. Okay, everyone got that, right? Because the question, let's look back at the question. They say you are supposed to make 3 payments, right? 8,000, 4,000, 4,000. And payments obviously are money out of your pocket. So they should be negative, right? So what I'm going to do is I'm going to pull the formula here because I've done referencing of the cell. So this is the present value. All right, I can pull my reference up as well because in year 0, I mean, they'll take as year 0, so it's fine. I'm just going to do a sum. And this should be the answer. Yeah. Right, this is the answer. Everyone can get that? Everyone's good with this? So this is the answer, the summation answer. I'm just going to put in the formula text. So formula text basically gives you the formulas that's being used for the answers here. All right. So in case you miss out, these are the formulas that's given here. Everyone's good? Okay, but this method is a bit slow, don't you think so? We have to, for example, if we have cash flows and we have like 10 cash flows or 20 cash flows, then you'll be like, wow, you have to do it, I mean, you can actually just use a referencing, it's still quite fast. But there's even a faster method, and I would like to teach you that. It's called NPV, so net present value. And we'll talk about this NPV in much detail in the next few lectures, but we'll jump ahead a little to use this formula instead. So what's this NPV? So it's net present value. So basically, when we have multiple cash flows, we can use this formula called NPV, and it's even in Excel, to discount all your cash flows back to year zero. All right, so let me just pull out the NPV formula first. Now, the NPV formula asks you about the rate, which we know is 0.08. And then they say value, value, value. What does this mean? So when we see all these, we basically just put in we highlight the cash flows that is after year zero. So that means from year 1, year 2, year 3 onwards. So I'm going to highlight these two cells here. All right, so after year zero. This is an important part. Again, I want to repeat, for NPV, we only consider the cash flow within that formula, the cash flow after year zero. So year 1, year 2, year 3, etc. All right, so it's very easy. So you just highlight these two cells, you close it. Now, then you need to add back the cash flow at year zero. So what this NPV formula does is that it will help you discount your cash flows back to year zero, but you only include cash flows that are being discounted. So from year 1 onwards, we need to discount it, right? From year 2 onwards, we need to discount it. But for cash flows that need not be discounted, should be inputted outside the formula, which is what we did here, right? We put it outside the formula. And you see, we should get the same answer here. All right. Now, maybe you'll immediately see, oh no, why is it negative? So the idea of NPV, right, is that unlike the PV and FV formula where the signs are important, for NPV, right, it becomes not so important to put the sign. But at the end of the day, it still makes sense, right? Because at the end of the day, we need 15,133 amount of money to be paid for this what are we buying here? For your car, right? We're buying a car. So we do need the amount that is paid. That's why we have this negative. So I want to highlight again that the NPV formula is very powerful in the sense that you can just highlight this cell that you want. But what's important is that you must only consider the cash flow from year 1 onwards, year 1, year 2, year 3. We do not consider the cash flow at year 0, which is why we put it outside the formula. All right, I hope everyone's okay with it, okay with this question. So at the end of the day, we see that actually option 2 is cheaper. So we should take option 2. Okay. Again, we have one more question here. Okay, yeah. So my NPV was also negative. So just now, yeah, I mentioned for NPV, the sign is usually they don't convert the sign, right? So for PV formula and FV formula, the sign becomes very important, right? But for NPV, right, the formula basically do not really consider money going in of your pocket or out of your pocket. So it basically just takes whatever sign that is that's being shown in the cash flows, right? In year one, year two cash flows. Yes, that's right. That's right. You're right, Catherine. So if for MPV, if you want to use the MPV formula, if it's for 20 years, it will be from year 1 to year 20. Then you must plus back year 0 if there's any cash flows in year 0. But that's outside the formula, right? Plus back year 0's formula, cash flows. All right, so we have more question here. So suppose a broker calls you and tell you that he has this great investment opportunity. You have, if you invest $100 today, you'll receive $40 in 1 year, $75 in the 2 years, in the second year. Your required rate of return is 15%. Should you take this investment? So this is, we can do it the manual method, right? So we have a timeline here. 0, 1, 2. We know that we are receiving a $40 in year 1 and $75 in year 2. So we can use, we can almost use like the rabbit hop method. So we need to discount it by 1 year here, and we need to discount it by 1, 2, right? You hop backwards by 2 times. So this can be done using the MPV formula, or we can do what we have done earlier, to just use Excel to do it. And you know what? I'll just show you how to do it in Excel again, since it's the first time we are doing things. So for year 0 is 0, right? And this question says that if you invest, you'll receive money. So receive money is positive. So receive money, so we are receiving $40. And we are receiving $75. All right. Now the rate here, I'm going to change it. They say the question is the required rate is 15%. So I'm going to, I'm going to change to 15%. And I'm going to change this. You know what? I'm just going to pull it down. Okay. So what you should get is this $91 here, right? Now, if I want to use MPV, I can change this to 15% here as well. And I should get $91. It's basically the same thing. Okay. So in this sense, why is it negative? Because you have to pay the broker, right? For the investment. So you pay the broker and then you'll get $40 and $40, $75. Okay. Okay, so we have talked about multiple cash flows, and so far we have used the Excel. I always tell you, you can use Excel. You don't really memorize formulas. Use your PV in Excel. Use your rate. Use your FV, and just now we have learned using your MPV formulas in Excel. All right. Now in this idea of perpetuity, now I want to highlight to you that formula is important because Excel cannot do this. Okay, you need to memorize this formula, or not really memorize, but know that this formula exists and use the formula for the questions. All right, so this is important. You need to use formula. There's no Excel to help you to do this. You need to understand how this formula works. So I'll explain to you how this formula works. So first of all, a perpetuity means that it is a stream of cash flows, equal cash flows. Important is equal, meaning that the cash flow doesn't change. So you always get the same amount. So for example, you get $100, you get $100 forever. Forever meaning until infinity. All right. So the question is, if you're getting $100 until infinity, how much is this $100 worth today? And so this beautiful formula here basically tells you what is the present value of your $100 that you're getting forever until infinity. All right. And so there is no Excel to do it for you. There's no Excel formulas to do it. So you just need to use this equation to do it. All right. Now, there's one very important concept here is that the first payment starts one period from now. So what does this mean? Imagine I have 0, 1, 2, 3. All right. So in order to use this formula, your cash flow C must start from year 1 period from now. So if I'm at year 0, the cash flow must start from year 1. Okay. And yeah, this is the case. And I think I have one example that will show you critically why we need to understand the concept of first payment starts 1 year from now. But just keep in mind that this is super important. If it's not 1 year from now, we need to do adjustments to it, and we'll see how to do it. Okay. So let's do a simple example first. Imagine you have this British consul, which is like a perpetual bond, meaning that it's going to pay you £15 each year forever. And you know your interest rate is 10%. So what do? Remember, based on the formula, you just take C divided by R. So C is the cash flow. So you know that it's forever, right? 15 forever. So it's 15 divided by 10% and gives you this. And can you see that in order to calculate what is the present value in year 0, your cash flow must start from 1 year from now. So it starts from year 1, right? So it meets the requirement of using this formula, right? So I repeat again, the requirement is that your cash flow must start from 1 year from now. All right. So this example would highlight to you the importance of this requirement that has to be met. So let's read this question here. And again, remember, there is no Excel to do it, so we need to know the formula. So in order to create an endowment, which pays 100K per year forever, how much money must you set aside, right? How much money must you set aside today if the interest rate is 10%? Okay, so part 1 of the question says, the first payment start 1 year from today. All right, so if they say the first payment start 1 year from today, did we already meet the requirement of using the perpetuity formula? Yes, perfect. Yes, we met the requirement. So 0, 1, 2, 3, 4, 5. All right. So they say in the first part, first payment starts 1 year from today. So I'm just going to use C, C as the cash flows, which is 100K. All right. So C, 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 C. And so it meets the requirement. So it becomes very simple. So we just take the cash flow C, which is 100K divided by 10%. 100K divided by 10%. And it should give you this answer here. All right, so it meets the requirement, so it's easy. Okay, I'm just going to erase away this to answer the second part. Now, the second part is asking you, the first payment starts 3 years from today. Okay, so let me just erase all these various C. What does this mean? Where does the payment starts? Can we see that the payment only starts 3 years from today? Year 3, that's right. Year 3, yeah, perfect. So it's C, C, C. Okay, everyone can see that, right? It starts only in year 3. Okay, so pay very careful attention now. So remember, the requirement of using the perpetuity formula is that the payment starts 1 year from today. Okay, and we know that that's the only formula that we can use for perpetuity, right? So what happens now? What is 1 year from 3 years from today? Okay, this is a bit confusing. What is 1 year from the 3 years from this C? What's 1 year from 3 years? It's actually year to, no, one year from, okay, so 1 year before, because 1 year from today, right? So what is what's 1 year before the 3 years is actually year 2 here, right? Okay, so if I want to use the perpetuity formula, what is happening now is that basically I am discounting all the cash flows, or the C, back to year 2. So I'm discounting it all back to year 2 at this reference point here. All right. And how do I do that? We just use the perpetuity formula, right? We just take C, or let's just put 100K, divided by 10%. But this 100K divided by 10% is at year 2, right? Because remember, perpetuity formula considers the C 1 year from today. So imagine now year 2 is today. So this today is the reference point. And so all your C is being discounted back to the present value at year 2. But the question is how much, okay, so everyone got this part first about the reference point before we move on to step 2, right? So anyone has issues, feel free to unmute yourself or type in the group chat. Everyone's okay with this reference point that we have to consider year 2 as the reference in order to use this perpetuity formula, because the perpetuity formula requires the cash flow to be 1 year from today. So imagine year 2 is the reference. All your cash flow is happening in year 3, year 4, year 5. Everyone's okay? Any questions on this reference? We are good? Okay, if we are good, then now we need, but remember the question say, how much money must you set aside today? So today is year 0, right? Today is not year 2. So what happens here? So we know that this equals to 1 million, right? 100K divided by 10% is 1 million. So this 1 million, what must you do? This 1 million here must now be discounted back using the PV formula, right? And how do you do that? We need to do the bunny hop, right? How many times does you hop back? 1, 2. So you need to hop back twice, right, to year 0. Why you want to hop back to year 0? Because the question is asking you how much must you set aside today, not how much must you set aside in 2 years' time. How much? So the question is how much must you set aside today? So you need to do a hop back of twice. So we can use the PV formula, or you just simply take 1 plus 10% divided by to the power of square, right? Because you're hopping back twice. So this is the PV formula. So PV, so if you reference back to the PV slides, this is the PV formula, right? FV, so PV equals to FV divided by the rate to the power of the number of periods. So this is what I do. So if you type this in, you should get this answer here. Or if you want to do the Excel method, you can simply do Excel as well, right? So Excel, that you can put in the various numbers. You know what? Let me just show you how to. It's the usual PV, but let's just show you how to do it. So let's say I do the Excel method. So PV equals to what's the rate? 0.1. Okay. Number of periods, remember we have to hop back twice, so it's 2. Payment is 0. We are not doing any payments. What's the future value? The future value is 1 million, right? We calculated earlier. Right? So this is the answer that you should get here. All right. So everyone can get that. So we see that what's important is that when we use the perpetuity formula, we need to consider it as 1 year from today. So the concept of 1 year from today becomes very important when your cash flow doesn't happen in year 1. It happens in, like in this example, in year 3, which is why we need to first take the reference from year 2. So we take a reference from year 2, all right? From this reference, we can use a perpetuity formula as what we see here, perpetuity formula, a reference from year 2. Then once we calculated the value of 1 million here, then we need to use the PV formula, right? Which is what we saw in Excel, or can use the manual PV formula, which is what is given here. We are good. Any questions? Okay. As usual, if any questions along the way, feel free to type on the chat. We'll move on. All right. So just now we talked about perpetuity, right? Meaning that we're getting the same amount of money, $100 forever to infinity. Now, we're going to make it a bit tougher. We're going to think about growing perpetuity, growing. So what does this mean? It means that $100 that you're getting will grow at a constant rate. And this rate is given by G, all right? This rate G. And this is the growth rate of the form of the cash flows. All right. And because you have a growth factor, we now need to use this growing perpetuity formula, which is PV equals to C divided by R minus G, where G must be less than R. If not, you will not be able to use this formula. All right. So this the assumption or the requirement to use this formula is that G must be less than R. G meaning the growth rate must be less than the interest rate R. That's the first requirement. And the second requirement is that, again, because we are just doing a modification of the perpetuity formula, your C must be 1 period from today. So there are 2 requirements now. G must be less than R, all right? And C is again 1 period from today. Okay. I want to repeat again that the growing perpetuity formula, growing perpetuity has no Excel as well. So we need to know how to use the formula. Okay, let's look at this example here. The expected dividends next year is 1.3, and dividends are expected to grow 5% forever. And we know that dividends are paid every year forever, right? So, and since it's growing, we know we can kind of think of the growing perpetuity kind of formula. So what's interesting is that you notice this question did not say this is a growing perpetuity, right? So questions can be a bit vague. So we need to analyze it and understand, okay, this, you know what, could be a growing perpetuity question. And in fact, this is actually a growing perpetuity question. So you should be able to identify that this is a growing perpetuity question, and we need to use growing perpetuity formula. Discount rate is 10%. All right. So, so what does this mean? So can you see that dividend next year? So these are very important. We say the dividend next year is 1.3. So next year meaning what? So now is year 0. Next year is 1.3. So 1.3 is already given to you. So we can use the growing perpetuity formula. We just take the cash flow next year, which is 1.3, divide by 0.1, which is the rate R, right here, discount rate, and minus the G. So this is your present value of the growing perpetuity. Right? So remember earlier on, I said that we'll talk about 2 things, stock valuation and bonds, which we'll cover today. So using time value of money, what we can do is we can calculate the value of a stock. And how do we do it? We use this concept called the Gordon growth model or the constant growth model, right? And how does this model work? The model works simply using dividends. So they value the stock based on the dividends that is given by the company. Okay, so it actually uses the growing perpetuity formula. Can you see here? Okay, so can you see that div1 divided by this is actually growing perpetuity, right? Remember, growing perpetuity is C divided by R minus G. And C is 1 period from today, right? Remember, I keep on emphasizing 1 period from today. So this dividend div1 is actually 1 period from today. Now, why is there this component here? So this component basically is the same as div1, right? So what is div1? So div1 is actually div0 growing by 1 year, right? Which is div0 growing by 1 year. That's why we have this. So if this algebra is a bit confusing, let's see this thing again here, right? I'm just going to repeat here. So can you see here? What is 1 period from today? So this is given as C. So 1 period later, you'll grow by 1 plus G, right? So in the same sense, the dividends will grow. So this is how we value stocks. We have one example. Let's see this example here. Okay. Suppose the incorporated just paid dividends of 0.5. Okay. When you read a question, you have to be very careful. Just paid. So what does this mean? Anyone can say, what does just paid dividends of 0.5 means? Very good. div0. So div0 is actually 0.5. So on a timeline, I'm just going to draw the timeline here. All right, we have div0 here, which is 0.5. So remember, in order to use the perpetuity formula or growing perpetuity formula, we always need to consider 1 period from now, right? Which is, in this case, div1. Okay. They say that the increase in dividends is 2%. So this is a G, right? Market requires a 15%. This is your R. And how much is the stock being sold? So we know that we can use the growing perpetuity formula, but pay attention that this is div0 that's given here. So we know that growing perpetuity formula, we take the cash flow 1 year from today, meaning present value equals to 0.5, 1 plus 2%, right? Divided by 15% minus 2%. So I'm using the growing perpetuity formula here. And again, I want to repeat why I did this part here is because the question says just paid. Just paid is year 0. So remember the conditions to use the growing perpetuity formula is that the cash flow has to be 1 year from today, which is why we have to put 1 plus 2%. So, okay, so that's all for perpetuities. Now we have this another. So just now, okay. So do a quick recap. So we talked about present value. We talked about future value, right? That's the most basic one. Then we talked about perpetuities where the cash flow keep on going on forever. All right. Now we are going to talk about one more thing or a few more things, but one of them is this idea of annuity and more specifically ordinary annuity. And what does this mean? So in a perpetuity, the cash flows are forever. They never end. Now, in an ordinary annuity, the cash flows will end at a given number of years. So the cash flows can be there for 5 years, and then after 5 years, it will end. So this is the idea of ordinary annuity. So it will grow. Okay, so it's not about growing. Sorry, there'll be cash flows, and the cash flows will be for, let's say, 5 years, and then you'll stop. And because of that, we are given this, formula here that looks like this for the annuity, ordinary annuity formula. So this formula looks a bit scary, but again, we just plug in the various values, C divided by R, which cash flows, and C divided by R. And again, this is actually a derivation of the perpetuity formula. So the cash flows is 1 year from today, all right? And then we plug in this so-called like a discount factor, right? The good thing, the lucky thing is that we can do this on Excel. So we don't really need to memorize this formula, but you should recognize this formula. Why? Because we will later have this growing annuity. So like perpetuity, we have a growing factor as well. And the growing annuity, we cannot use Excel. But the ordinary annuity, we can use Excel. All right? So that's the difference. So ordinary annuity, we can use Excel. So you don't really need to memorize the formula. But the growing annuity, we cannot use Excel. So we need to know the formula. And the growing annuity formula, like the growing perpetuity formula, it is like just adding a little stuff. So that's why try to just know that how this formula look like, and because we'll talk about it in the future or later in the slides. One thing I want to highlight here is that we'll talk about bonds for growing annuity in a bit. All right. So can we see now that for growing annuity, let's say in this case, it's $100 for 3 years. And so we can calculate what is the present value of this growing annuity. And if some of you might notice, hey, you know what? It looks very similar to, remember just now we did 2 questions on the various cash flows. You all recall that? The cash flows that we did, and we talked about NPVs. It looks very similar, right? Now, the difference is that for ordinary annuity, the cash flows amount are the same. Meaning what? The cash flows are not going to change $100, $200, $100, $50. It doesn't change throughout the year. It's just standard. So ordinary annuity is standard. Just now, remember when we did the NPV and we did the manual cash flows, the manual PVs, the cash flows changes, right? And there is no like growth factor or whatever, right? It just changes whatever. So the difference is that ordinary annuity is the standard, like what's seen here. So you know what? Let me just show you how to do it in Excel since we talk about this question. So how do we do it in Excel here? So we have PV. Let's put PV because we are calculating the present value. Now, in the question, the rate is 10%, right? 10%, so 0.1. The number of periods that we have is 3 years. Okay. Now, so the growing annuity comes in terms of, remember this thing I keep on saying, oh, payment, we'll talk about it later. We'll talk about it later, right? PMT here, we'll talk about it later. So now we're going to talk about this, which is the growing ordinary annuity. And so they say it's $100, right? We're going to get $100 for 3 years. So I'm going to put payment as $100. FV is 0. There's nothing to think about. And I'm just going to close it here. Can you see that I get the answer given in the question, which is 248.69. So in this question, because there is no context, we don't know whether it's money in or going out of your pocket. So let's just leave it as it is. All right. But maybe the next question, there is some context so we can put in the sign. All right, so we look at this example here. You can afford 1,500 monthly car payment. So you're going to make payment, right? Money is going out of the pocket. What is the maximum amount of car loan they can take if the interest rate is 5% for 7 years? Now, first of all, do you remember what we talked about in the rate? Can you see that this is monthly payment? And remember your interest rate 5% is, I always say is annual, is assumed to be annual. So in this case, we need to account for the difference in the compounding period. We need to calculate the period rate. Can everyone see that? Does everyone understand? We need to calculate the period rate here. And the periodic rate or period rate is 5% divided by 12. Why? Because the payments are in months. Okay, at this point of time, right, I want to highlight something that what you should do is always reduce the rate to a smaller denominator. What does this mean? So if we have monthly payments and we have yearly rates, use everything in months, all right? Let's say if we have year and semi-annual, always use semi-annual. So always use the smaller denominator or smaller kind of periods. And do not convert it up. What does it mean converting up? Converting up means that in this question, you have monthly payments and interest rate, which is based on years. Do not convert this into years. That means what? You want to times 12. Do not do that. Why? Because if you are going to convert it into, if you are going to convert this, sorry, it's too much. If you are going to convert this into years, what do you have to do? You have to take into account the compounding of 1500 for each month that you multiply by 12. So what does this mean? 1500 times 12. Is this correct if I want to convert it to years? And do everything in years? So is this correct? Can I do this to calculate, to work out this solution in years? No. Yes, that's right. You can't do that. And again, it goes back to the basic of time value of money, right? Because money that you receive this month and the 150, not 150, 1,500 that you receive next month worth different amount of money, right? And because they worth different amount of money, you cannot simply just take times 12 like this. So this is wrong. We cannot do this. We cannot convert it to years. So I want to repeat again that whenever you have months and years, always convert it to the lower denominator, lower period. So in this case, you have months and years, right? Months meaning the payments are months and the rates are years. Convert everything to months. If you have semi-annual to years, which is or annual, always convert it to semi-annual. Never convert it, all right? If not, you'll get the answer wrong. And that is because money that's worth this month is different from the money that's worth next month, right? Okay, so let's jump back to Excel to input this question. So we are going to do a PV formula here. Now, the rate, remember, we are going to do everything in months. So the rate of 5%, 0.05, I need to divide by 12 here. Remember when we divide by rate, when we divide the rate, what must we do to the period? What's the MPR now? Anyone can say what's the MPR in this case? Is it 7 or is it 84? Perfect, that's 84. Because we are using everything in months now. So it's 84. Okay, payment. What is the amount? And is it negative or positive? Because now we have context, so we can put in, is it positive or negative? And what's the amount that we should put in here for PMT? Yes, negative, very good. So I hope everyone can see it's a negative, because money is going out of your pocket, right? You need to pay the monthly car payments. So money is going out of your pocket, and this is money. So the question will give you money, perfect, which is 1500. The FV is nothing, right? At the moment, we'll just consider it, later we'll see some examples where there's some FV, right? Type is again 0, and we should get the answer here. So, what I like to do at the end of my formulation is that, think about it. Okay, this is a positive value, 106K positive. Does it make sense to me? Does it make sense to the question? It does, right? Because they say, what is the maximum car loan? So remember, loan, you're getting the money now, right? Which is going into your pocket. So yeah, it's correct. It's positive. It's supposed to be positive. And every month, you're supposed to pay out negative because money is going out of your pocket. So a good practice is to, at the end of the question, ask yourself, does this positive or negative value make sense to you? And hopefully it does, then you know you're on the right track. All right, and any questions regarding this? So, okay, so we have two more examples on ordinary annuity. And this one is about purchasing a car. Okay, so you are purchasing a car and you schedule to make 3 annual. Okay, let me just highlight important things. 3 annual payments at 4,000 per year. The first payment start 1 year from today, right? Remember, ordinary annuity, we need to consider 1 year from today as well. That's one of the requirements. Given the rate of interest is 10%, what is the price you are paying for the car? All right. And let's look at the second part here. Okay, now, let's just jump back to Excel to do it. So we're using PV again. All right. And what do we have here? The rate, they say, is 10%. All right. We need to make 3 annual payments. So this is annual, so it's 3. All right. What is the payment amount and what is the sign? All right, negative. Perfect, negative 4,000. I hope everyone is following with this. Negative 4,000, because we are making payments for this purchase of car. So it's money going out of your pocket. What else? FV 0, type is 0, right? And you should get this answer. So this is the, I guess the amount of money you have to loan to buy the car, right? You know what? Okay, so the next question, so refer to your notes. I'll not jump back here and there, so it will not be so distracting. So refer to your notes. The second part says that future value of, so find the future value of the payments. You plan to save 3,000 every year for 4 years. So I hope you are referring to your notes. Given 8% rate of interest, how much will you be how much will there be in your account after 4 years? So the question asking how much will you have at the end of 4 years, right? So at the end of 4 years is immediately a FD, right? So rate, they say is 8%, so 0.08. Number of periods is 4 years, we are considered as 4 years. Now, payment, is this a negative or positive, and what is the amount that it should be? Uh, so yeah, actually planning to save, right? So the money is actually going out of pocket into this account. So what's happening is actually a negative. Yeah. Okay, negative. I hope everyone can see that. Present value is zero because you have no money now. And you should get this. All right. So I hope everyone can see it was a negative 3,000. And at the end of the day, at the end, the FV is a positive. You ask yourself, does it make sense? It does, right? Because at the end of the 4 years, you'll get the money, right? The money is coming back to you. You're getting this money at the end of 4 years, which is around 13,000. So it's a positive value. So it's correct. So money is going in and you have to pay money going out. All right. So I hope everyone know that it's a negative here and why it's a positive here. Okay, so we'll take just a quick 6 minutes break before we move on to bond pricing. Um, and as usual, if you have any questions, just type in a group chat. Right. All right, welcome back. Hope you have a good short break. All right, so let's continue on to discuss about bond pricing. So the idea of bond pricing, before we talk about the details, is that we are going to use the idea of ordinary annuity. All right, so anyone know what's a bond? Have you had other courses that went through what's a bond, what's a bond like? So yeah. So some of your okay, that's good. That's good. So some of you all know what's a bond. Okay, so for the benefit of everybody, I'll just explain what's a bond so that we can understand the concept. All right. So a bond is like a debt. That's right. Now, how do you think about the bond? So again, I'd like to give the intuition behind a bond. So how does a bond work is almost like we call it an IOU. So I owe you. Basically, it's a piece of paper. A bond is just a piece of paper. And how it works is that, you know what? Let's say a company needs some money, right? And so the company that requires the money, say, goes to the market or approach you, right? Let's make it simple. Here, the company approach you and say, can you lend me some money? And in return, I'll give you this paper, right? And this paper is called bond. And this paper basically says that, oh, you know what? At the end of the day, I'll pay you back the principal and I'll give you some kind of interest, right? Some kind. We'll talk about the details of the interest in a bit. And so a bond is simply just a piece of paper that the company is saying that they will promise to pay you the interest plus your principal in the future. All right? So that's a bond. It's a piece of paper. Now, the bond is unique in the sense that it's not like a loan. Why? Because in a bond, the principal, okay, let's talk about very plain bond. So those that have more advanced knowledge, you know that this is not the kind of only bonds that we have. But let's talk about the most basic bond. The most basic bond, right? In the sense that when you give the company $100, right, for this piece of paper, which is a bond, the company will promise you that they'll pay you back $100 at the end of, let's say, 3 years. Now, the question is, hey, I'm giving you $100 and you're going to give back $100 to me at the end of 3 years. Where is the interest that's happening? So the bond is unique in the sense that the interest that you receive from the company, because you loan the company the money, right? So the interest that you receive is in the form of this thing called a coupon payment. So the coupon is paid to you every year, or not every year. It can be every month. It can be every semi-annual. So again, we need to use the concept of, converting it to the lowest base, right? Remember, lowest base meaning that if it's semi-annual and yearly, you always convert to semi-annual. So we need to convert the base, and in that sense, the coupon payments are actually your interest that you receive for the bond, and that's why the bond is unique. So the bond is unique, and it's not like a loan because the interest comes in the form of coupon payments. All right. So how do you determine the coupon payments? It is based on this concept of on this rate called the coupon rate. So the coupon rate is very unique to the coupon payments, right? And basically, to find what's the coupon payment amount, we simply take the coupon rate times the face value of the bond. So face value of the bond means that how much you loan the company, right? So let's say we talk about $100, right? So the face value is $100. Now, we have a face value or par value, which will be repaid at the end of the loan, or in a sense, the bond, Remember, I mentioned that at the start, you will give the company $100, and the company will give you a piece of paper that tells you that at the end of the 3 years, let's say, they'll return you $100. But every year they pay you we know that now the interest comes in terms of coupon, right? So what's interesting is that in this bond, we'll receive the face value back at the end of 3 years, which is the principal. And because we receive the face value back, we need to consider FV amount already. Later we will see some example of this FV amount, but we need to consider FV at the end of the let's say 3 years, right? And the maturity date, of course, if it's 3 years, the maturity is 3 years, right? 3 years maturity. Yeah. So everyone is okay? Everyone understand what is a bond? So we have a coupon rate, we have a coupon payment, which is like an interest that's paid to you. We have a face value, which is the ending value, and then we have the maturity. So in that sense, right, a bond is, like I mentioned, is ordinary annuity because there is a fixed period, and we know that we are receiving coupons every year, and the coupons are like their interest, right? So they're receiving coupons. So the coupons are like cash flows that's coming in. Now, why is there this portion here? What's this par divided by 1 plus r to the power of t? So this is basically your FV that will happen. All right. And again, you don't have to worry too much because what happens is that we can use Excel to do it. So we don't have to remember this formula at all. All right. But what's important to take note of is that coupon payment can be annual and semi-annual. All right. And therefore, we will have to do adjustments, like what we have done previously, to convert it to the lowest base. I repeat again, it has to be converted to the lowest base. So if it's annual and semi-annual, convert to semi-annual. All right. And your R is your yield to maturity or your discount rate. Okay, this is important that the yield to maturity, YTM, or discount rate is not equals to coupon rate. Those are two separate rates. The coupon rate determines the amount of coupon payments that you get from the bond. So coupon payments are like interest payments. All right. And your yield to maturity is your discount rate of your bond. How much are you going to discount the bond? So we have an example here to explain to you this calculation of a bond pricing. So we're using a PV formula this time. So we see that so they're asking you what's the price, so what's the PV of a 5.5 annual coupon bond. So what does this 5.5 means? Anyone can say, can suggest or kind of know what does this 5.5 means? So maybe this is new. So the 5.5 actually gives you the coupon rate. So this is the coupon rate. 5.5 is a coupon rate. A face value, they tell you what's the face value, and it matures in 3 years. And this is annual. So important to take note that it's annual. Sometimes it can be semi-annual. So then we need to convert everything to months. Remember, we always convert to the lowest denominator. Assume a discount rate. So this discount rate is the yield to maturity. So in a bond, there's a very specific name. It's called yield to maturity, right? What's the yield if you hold the bond to the maturity? So there is a specific term for it called yield to maturity. All right, so we can use the ordinary annuity formula. Let me just jump back to Excel to show you how to do it. So I'm going to pull up my PV formula. We know that the rate or discount rate, or we say yield to maturity is 0.035, right? It's 3.5%. Now, number of periods, we know that this is a 3-year bond. Okay. Payment. Can anyone say what's the payment amount for this bond? And is it a positive or negative amount? remember the payment equals to coupon payment. So what's the amount here? Okay, this is the first question. So yeah, no, actually it's not that. So the payment is the coupon rate times the face value, right? Remember your payment is your coupon payment. So how do you calculate coupon payment? Coupon rate. So what's the coupon rate? 0.0. Okay. Coupon rate is 0.0055. No, 0.055. Right, 5.5%. Times what's the face value? Face value is 1,000. Yeah. And this is a positive value because you're receiving interest, right? Money is going into your pocket. So it's positive. So it's correct. It's positive. Now, what is the FV? What's the FV here? Okay. Is a positive or negative? I see some is negative, some is positive. So it's actually positive because you are getting the $1,000 back, right? Remember what's happening here? I'll repeat again how the bond works. So imagine a company approach you. They say, I want to issue a bond. I need some money. I issue a bond. You are going to give the company money, and the company is giving you a piece of paper. At the end of the maturity, at the end of 3 years in this case, the company is going to return you the principal, right? And in terms of the interest comes in the form of a coupon payment, which is what we calculated here, 5.5 times 1,000, right? So the coupon payments are money going into your pocket. At the end of 3 years, the face value or the money that you lend the company is going to be returned to you, right? The company is going to take your money away. And therefore, it is a positive 1,000 to you. And we get this. Does this make sense? Does this negative make sense? No? Okay. Okay. Yeah. Okay. So those that do not know why is it negative? Okay, so this negative makes sense. Why? Because remember at the start of the bond, you are going to give the company the money, right? So remember, we're always thinking about money from your perspective, from your pocket. So at the start, the money is going out of your pocket, right? You are going to loan the company the money, and the company is giving you a bond. So it's negative, right? Money is going out. Okay. So at the start, you're supposed to pay this amount of money to the company. And at the end of it, the company is going to give you 1,000 and various coupon payments, which is interest payments. Okay. And so the negative should make sense because the money is going out of your pocket at the start. You notice also the total, can you see the total amount that you have to pay at the start for the bond? The money going out of your pocket is more than 1,000, right? Because there are some various coupons that are basically like interest. That's why it's more than 1,000. Everyone's okay with that? With these bonds? How we calculate bonds? So this thing here, this FV that we think about, is basically in Excel is the FV equals to 1,000 at the end that we have to put in the Excel formula. And that's because you are receiving back the principal that you lend to the company. So when remember receive back is a positive to you, and the PV that we calculated, PV equals to a negative, right? Negative 1,056. And why is it negative? It's because you are paying the company this amount of money to buy the bond, right? So everyone's okay with the bond. That's all we have for bond. I want to repeat here again that do not worry. There are more questions which have will be covered or is covered in the lecture 2B recording. So what I'm covering here is like one or two examples, but there are a lot of examples. I think over 20 examples that I've covered in the recorded lecture. So we'll go through all the various formulas that we have learned and how to apply them in various questions. Because time value of money at the end of the day is like mathematics. So we need to be exposed to like various type of questions and how it's being asked. Right. Okay. So far we have always talked about this thing where type. Remember the idea of type. So I'm just going to the next slide first. Remember this thing where I would say, oh, type equals to 0, right? But type equals to 0 means that the cash flows are occurring at the end of the period. What does this mean? At the end of the period, meaning that I'm just going to jump back to the previous slide. So they are occurring here, right? At the end of each period here. But we have this thing called annuity due. Annuity due means that the cash flows are occurring at the start of the period now, the beginning of the period. And if we see question regarding annuity due, this word due, then we need to do what? We need to consider in our Excel formula that type equals to 1. All right, this is important. So in terms of all questions, is assume, okay, so you should probably write this down if you feel that it's better to write down. You should assume that it's always ordinary annuity, meaning type is 0. So the cash flows are happening at the end of the period. Only otherwise stated in the question as beginning of the period, then we should use type equals to 1. So all questions is cash flow at the end of the period unless otherwise stated. All right. So what do we do? In terms of Excel, we just put 1. It's quite easy. But in terms of formulas, we just, in order to convert ordinary annuity to annuity due, we just need to multiply it by 1 plus R. And that's all. We just need to multiply. So that's to convert it from ordinary annuity to annuity due. So why do I even show you this if you can do it in Excel? That's because in the next slide, we're going to talk about this thing called growing annuity. And whenever there's a growth factor or this idea of growth, there is no Excel formula to do it. Remember? So there are 3 formulas so far that there's no Excel to do your calculation. So it can be perpetuity, a growing perpetuity, and now what we're talking about is a growing annuity, right? So in terms of a growing annuity, there is no Excel formula. We have to use the equations to do it. And if the questions say growing annuity due, so remember, this due function can be applied to either ordinary annuity or growing annuity. And if it's a growing annuity due, then we have to implement this formula here. Of course, we know that Excel, we cannot just put 0 or 1 in Excel, right? So that's why I want to highlight this 1 plus R here. All right, so growing annuity is basically the same as a ordinary annuity, but now our cash flow, remember ordinary annuity are getting standardized cash flow, right? But now a growing annuity means that the cash flow would keep on growing by the factor G. So in terms of formulation or formulas, this is a formula that you need to memorize or you need to be familiar of to calculate the present value of the growing annuity. So if you have your slides in front of you, you can just flip back to your ordinary annuity. You notice that the formulas are very similar, just that we now need to consider the growth function here and here, right? The rest of the formulas are the same. So we have this example here. A retirement plan offers 20K per year for 40 years and increase the annual payment by 3% each year. What is the present value at retirement if the discount rate is 10%? So because it is increasing every year, it's a growing annuity, we plug in the various values here, right? And we plug in the growth factor 1 plus G, 1 plus R, R minus G here, right? And then we have, it's 40 years. So we can calculate this. So there's no Excel to do it for you. Okay, so earlier on, when I asked the question, I think two of your classmates mentioned about this idea of a decreasing interest, right? And then I'd say, oh yeah, that's possible if there's an amortization. So we are going to talk about amortization now. So what is amortization? So amortization means that the loan amount will keep on decreasing, right? Because you're going to pay interest per year. Every year. So let's say you have in this case, a 3 years loan. Yeah, 3 years loan. The loan amount is going to change, and therefore your interest amount is going to change every year. So the question is, how do you construct this so-called amortization table to determine the, let's say, the various interest payment, right, for each year? All right, so we are going to do it here to construct amortization table. First of all, how do we construct amortization table? The first step is to first determine, okay, so you are taking a loan of 1,000, the annual rate is 10%, and there are going to be 3 equal payments, right? So the first step is to calculate what is this payment amount. We need to calculate payment amount, and we use Excel again. We put in the payment formula, PMT. We put it as 10%. We have three values, and we have 1,000 here, right, as the present value. Because remember, we take the $1,000 loan. So we are able to calculate that payment is this, which makes sense, it's negative, because you have to pay for your loan, right? Your present value is positive because the money is going in your pocket, right? 1,000, you take in a loan, it's going to your pocket, 1,000, and every year you have to pay $402, right? Which is negative because you have to pay, so the money is going out. Now, once you do that, once you have calculated your payment, we know, okay, I'm going to skip. So this is a calculation, but I want to show you the table which would explain to you very quickly how to calculate it. So once we calculated the payment amount here, all right, which is constant, you are always going to pay this amount for the 3 years period. We know that we have a beginning balance, which is the beginning loan amount, 1,000 here. We know that we are going to pay this in the first year. Then how do we calculate the interest? So interest is basically, we take the beginning balance times the interest rate. What's the interest rate? It's 10%, right? 10% is the interest rate here. So that is 1,000 times 10% is $100. And how do we calculate the principal payment? Principal payment, we just take PMT. Sorry, not BMT. PMT minus interest amount, right? So we get 302. That is the principal amount. And what is the ending amount? Ending amount, basically what we take is beginning amount. So beginning balance BB minus principal payment. Right? So we just take 1,000 minus 302. So there's the ending amount of your loan. So this kind of loan, right? What is happening here? In terms of like the idea behind what's this loan, the idea is that the loan amount will keep on decreasing. And because of that, right, your interest amount that you pay will keep on decreasing. But every year, you are still going to pay the same amount of payment amount, right? The payment amount here will be the same. And because of that, yes, your principal amount would change as well. So what's happening here? So this block of values will keep on changing, and you will notice your principal will decrease and your payment amount will increase over time because your payment is the same. That's right. So this is important. Interest declines over time. And this is a 3 years amortizing. So at the end of the 3 years, you should have zero loan, right? Because you pay off all your loan already. So this is a pictorial representation. See, can you see interest is this dark gray? So your interest amount would decrease. Can you see your interest amount here? Is like decreasing, right? But your principal amount is increasing. But at the end of the day, you are paying the same amount of money of PMT every year. So this is a unique thing about the amortizing loan. So what I recommend is that you should at least try once to reconstruct such a table in Excel, or you can prepare this in Excel. In case for your finals, they ask you to do an amortizing loan, you need to know how to construct this in Excel. All right, it's quite simple. Once you do year one, you can just drag the formulas down. Right, and this is basically the derivation of how you calculate it. Okay, everyone good? That's actually more or less for time value of money. The last component that we're going to talk about is inflation. It is an add-on to the idea of time value of money that we have to consider. All right. So now is actually a very good time to talk about inflation, because like all of y'all should probably read or even experience it, right? Like yourself, like sometimes you buy food from the grocery store, things are very expensive because of inflation. And the idea about inflation is that the inflation rate comes about based on the idea of this thing called CPI, which is Consumer Price Index, right? The Consumer Price Index, or CPI, gives you the inflation rate. Whatever we have talked about, remember, has always been the nominal interest rate, or the APR. Let me talk about APR, right? Which means that is the rate that money grows, but it does not account for inflation. What does this mean? That yes, your interest rate or nominal interest rate might be 10%, but it does not mean that you can buy 10% worth of products in year one, year two, in year three. So every year, we know that because of inflation, we will buy less and less products, even though our returns is 10%. And so because of that, what must we do? We need to calculate this idea called real interest rate. And the real interest rate is the rate that accounts for inflation, and basically is the rate we call the rate in which the purchasing power investment increase. So that means if the real interest rate is 10%, it means that it has taken into account the inflation. And it means that for every year, we can buy 10% worth of goods after considering the impact of inflation. All right. So we have the nominal rate and the real interest rate that we discussed about. Now, the important thing to take note is that when converting between the nominal rate and the real rate, we must always use Fisher equation. This is very important. So let's say nominal rate I norm is 3%, inflation, which is usually given by I equals to 1%. We cannot just take nominal plus inflation, 4%. So the real is 4%. Actually, no, the real should be less, it should be minus. So you cannot say, the real is 2%. So 3 minus 1 equals 3 minus 1 equals 4. 3 minus 1 equals 2. We can't say that. We need to always use Fisher equation, and we plug in the nominal rate amount the inflation amount to find what is the real amount. So whenever there's questions regarding inflation, always straight away recall Fisher equation. And if you want to calculate real rate, we need to use the Fisher equation. I think we have a few examples. So the first example, we know that interest in a 1-year government bond is 5%, inflation is 2.2. So what is the real interest rate? So we plug in the nominal. So this is the nominal amount. We plug in the inflation. And remember, inflation basically eats up your return, right? So the real rate should be lesser. So it's also kind of like an intuition, right? If you calculate and then you realize that, hey, my real rate is bigger than my nominal rate, that means something is wrong, right? Because inflation is supposed to reduce your nominal, right? It eats up your return, right? So in a sense, oh yeah, okay, I get the real of 2.74, which makes sense here. And this is using the Fisher equation. Okay, so because in time value of money, we always talk about cash flows, right? Cash coming in, cash coming out. So we need to be careful when we think about nominal cash flow and real cash flow. So far, before we talk about inflation, all the cash flows are nominal cash flows, right? So basically, because we use the nominal rate to discount them, right? We use the APR to discount them. And those are not, it doesn't mean that we can buy 10% worth of goods every year, right? We know that the amount of goods we buy will decrease based on the cash, even though we have this amount of cash flow. So if we consider real cash flow, then we must use the real interest rate. So what's important here to highlight is that when we want to calculate constant dollar or real cash flows, we need to use real rate. And whatever we have done so far has been always using nominal discount rate because we are calculating the nominal cash flows. So we have an example here to try to help you distinguish where and how does this real and nominal cash flow come about. So you own a lease that costs you 8K immediately, increasing 3 years based on the forecast inflation for 3 additional years, so a total of 4 years. Now, if the discount rate is 10%, what is the present value of your lease based on nominal cash flow? So, and the second part is based on real cash flow. So in terms of nominal cash flow, what's happening here? We know that there is a increase, the so-called the cost of the lease is going to increase by 3% each year, and your discount rate is 10%, right? So your increase every year is almost like your growing annuity. You see, it's a growing annuity. But what's more, because you're going to pay your lease now. Now meaning what? Let me just draw a timeline for you. So remember just now I mentioned about how the annuity can be annuity due, but it can be a growing one. So that's why we need to know the 1 plus R. Remember the big red dot that I draw. So yeah. So what's happening here is that in this sense, there will be a growth, or you need to pay let me see this question again. We need to pay the lease. We need to pay the lease now, immediately. So year 0. So we are going to pay C as the payment. C, right? And this will be for 3 years, right? 1, 2, 3. So can you see that this is a due issue? It's no longer ordinary annuity. It's annuity due. All right. So, and because it is growing, because we know that there's a inflation rate that's going to increase by 3% a year. So there is the growth factor. That's why we are using the growing annuity. This is a growing annuity, and this is the due function. All right, and so as we know, for growing function, whether it's a growing annuity or a growing perpetuity, there is no Excel to do it. We need to use the equation so we can get this. Now, this question, the first part is treating the cash flow as nominal, right? We're treating the cash flow as nominal. Next, I want to highlight the next one is that we're going to treat the cash flow as real. So what's happening now? So remember when we deal with real cash flows, we always need to calculate Fisher equation because we are going to use the real discount rate, right? So real cash flow must use real discount rate. So in this sense, the real discount rate is calculated here using Fisher equation. And after calculating the real discount rate, we don't need to consider the growth factor because we have considered it as part of the Fisher equation. And therefore, after that, we can just use the annuity due formula. And you know, annuity due, we don't need to use this, right? We can use Excel to do it. We simply plug in this value here to note that type equals to 1. Everyone's okay with this? Any questions? May I just pause here for a short while? Any questions regarding this idea of real and nominal? Okay, well, I guess we are okay. All right, so let's look at one last example regarding, again, the adjustment of the rates based on real and nominal, right? Because sometimes it can be a bit confusing, like, okay, where should I use real or should I use nominal? So let's look at one more example. And don't worry, for your pre-recorded lecture 2B, there are more examples of this real and nominal as well, right? So you have reached age of 60 with a modest fortune of 3 million, and considering early retirement, a nominal interest rate is 10%, inflation is 5%. All right, so the question, first part is, how much can you spend each year for the next 30 years, assuming that your spending is stable in nominal terms? What does this mean? So I've provided you the explanation. So what does this mean? So since the spending is stable in nominal terms, it means that the spending amount is fixed every year. But because of inflation, you will buy less and less things. That's all, which is basically what we have done so far, right? Remember, for most of this lecture, before we talk about inflation, we have always just talked about everything as nominal, right? We don't even care about inflation. So in this first part, it's as if we don't care about inflation at all. It's just that we know, after calculating whatever value here, is that this amount of money will buy less and less things over the number of years. So I'll not jump to Excel, but you can do it in Excel to calculate the payment. But I've given you the various inputs here because we know that it is for 30 years, right? We know that it's a 30 years. The present value now, we know that we have 3 million. We have 3 million. So, and we have 10%. FV0, because when you pass away, there's no more money. And the type is 0 because it's ordinary. There's no due function here. And so you plug all this in Excel using the PMT formula, we should get this amount here. Now, this is nominal, which is what we have done so far in most of the lecture. I'm just going to hop back to the previous slide. And here they say, assume that spending is stable in real terms. What is the amount that you will withdraw from the account in year 1 and year 30? All right. So now we need to consider real terms. What does this mean in real terms? So real terms means that you need to consider how much money must you set aside to compensate for the inflation that's going to happen as the year go on. So once we need to consider real terms, we again need to use Fisher equation. So let's calculate what is the real interest rate. We plug in the 10%, we plug in the inflation amount of 5%. So we get this, right? Then we use Excel to calculate PMT again, the same way, but we are using the real interest rate now. So we assume real in order to calculate what is the payment required, or the payment that you receive for the next 30 years. Before we go on to to this part here, just quickly flip back. Can you see that? Do you notice something? The payment here of the amount that you can spend, 318,238, versus the real amount of this is so much lesser, right? The real amount is lesser. Does this make sense to you? Everyone can, does this make sense to you why the amount is lesser? Yeah. Okay. Yeah, because of the inflation, right? The inflation reduced the amount of payment that you receive. Yeah. So you're on the right track. So I don't know, like whenever you try, when you solve a question, try to put the answer into perspective. Ask yourself, okay, does this make sense? Like if your calculated real amount is more than your nominal amount, then something is wrong. So you try to make like I don't know, examine the answer in the perspective and ask yourself whether it makes sense. So yes, okay, this one makes sense. It's lesser, the real amount is lesser than nominal amount. But the question did not ask you about the payment, right? What's the question asking you about? What is the amount you will withdraw from in year 1 and year 30? So you need to calculate what's the amount that you can withdraw in year 1 and year 30. So in year 1, remember, in terms of this real amount, okay, what's happening here? So remember, at the end of the day, right, the concept of real is a virtual concept. Okay, what does virtual concept? It means that you are calculating on a piece of paper or in this question. In terms of the money that you take out from the bank, let's say this is about taking out money from the bank, right, to fund for 30 years that you are alive. In terms of the money that you're taking out from the bank, this is considered, they're all nominal amount. You can't take out real money out, so-called real money out, right? That is adjusted for inflation. There's no such thing. You always take out nominal amount of money, right? And that's why in year 1, we need to multiply it by 1 plus inflation to the power of 1. And in year 30, we need to multiply to a power of 30. So can you see immediately that, you know what, in year 1, I take out lesser money because there's less inflation. But in year 30, I need to consider the inflation to the power of 30. And the amount of money you take out in year 30 is a lot bigger, right? This is a big amount that you need to take out. And this is a smaller amount that you need to take out. And that's why this Fisher equation, the beauty of it actually helps you convert the amount that you need to take out into the real component. But then when you actually take out the money, I mean, based on this question, because I'm taking out money, the amount that you need to take out is based on nominal terms. So we need to convert it back to nominal terms. So this payment is based on real, right? And this here is based on norm, right? Nominal. So this is based on real. All right, I hope y'all can see that when we calculated in terms of real term, everything is real. But in real life, we cannot take out real money, we take out nominal money. So we need to convert it. All right. Do you have any other questions? Do you have any questions regarding what we have covered so far? So we have covered quite a bit. I want to repeat again that what we have covered is the other concepts. And I have actually taken out a chunk of a lot of the examples and put it under the idea of a lecture 2B. And for those that maybe came a bit later, so I mentioned that for lecture 2B is a mandatory lecture that you have to watch. I posted a lecture in our tutorial group. And this lecture 2B basically covers all the examples that were supposed to be in this lecture, because I felt that lecture 2 is a bit too much content if we go through all the examples and all the concepts. So I have just taken out the examples and put it under this lecture 2B. You should see here. This one is in the slides as well. And I'm just going to show you. So these are all the examples. So in the pre-recorded lecture, or lecture 2B, I go through all the examples step by step. And of course, if there's any question, we can go through the specific examples in the next lecture. But in terms of concept, we have covered all the concepts for lecture 2. And I'll highly recommend that you watch lecture 2B before attempting your TMA, because lecture 2B will give you a lot of good examples. Can't remember how many examples are there. Let's have a look. I think 20 examples, 21 examples. Yeah, there's 21 examples. So lecture 2B, I think is around 45 minutes. It will go through 21 examples in detail. So it help you understand the concept that we have went through today again. Okay, maybe I'll pause here. Any questions regarding what we have covered today? Oh, okay. So I see there's a question. What is CPT PMT? So CPT is compute. Sorry for the short form. So CPT is basically compute. So that means that's what you want to compute, right? All right. So maybe I'll stay here for a short while more, in case you have any questions. But those that need to leave, I know it's a bit late, so you want to go back for a good rest. Those that have no questions, thank you for coming. And we'll see each other next week. I want to repeat again that the lecture 2B is a mandatory lecture recording that you have to look through before you attempt your TMA, which will be useful. So thanks for coming. Have a good evening. Have a good rest.